You guys are brothers, right?
Yeah, we are.
Yeah. Okay.
Yeah, he's the older one. I'm 2 years younger.
Okay. And what made you want to start Fermat's Library?
So just for the people that don't know what it is, Fermat is a platform for annotating papers. And so if you want to think about it, you imagine a PDF view in your browser, and then you have annotations on the side that support LaTeX and Markdown. And so you can add annotations in parts of papers that you think are particularly tough to understand, or you think you could add more content there. But so it's something that we've done. The four of us that started Fermat, we all have a technical background. Mm-hmm. And so after college, we kept on reading papers. And every once in a while, we had this internal journal club where we would read a paper and present it to the others. So I remember, for instance, presenting a few years back, presenting the Bitcoin paper mm-hmm. to Louise and Mika, which don't have a CS background. And so you kind of have to go into, for instance, for the Bitcoin, you might have to go into, okay, what's a hash function? What's a public key encryption? And so we were already doing this. And we knew that you also have this behavior offline in places like universities. Mm-hmm. And so we wanted to take that experience and bring it online. Mm-hmm. And we thought there was a lot of content that you end up producing while you're trying to read a paper, which can be the most dense piece of content that a human can read sometimes, right? The language can be incredibly Spartan, and sometimes there's a step in some paper that they say, oh, this should be obvious, but then you mm-hmm. look at it and it's like, okay, I don't get it. Mm-hmm. And so we knew that there was a lot of content there that you end up producing while trying to understand a paper, and we wanted to bring that online.
Because Luis, you were in physics before.
I studied physics together with Mika, and João and Timer went to MIT. Timer studied economics, and you studied CS. Yeah. So a lot of the papers are around physics, math, economics, biology, CS, right?
Yeah.
Yeah, because that was, you kind of like solved the cold start by just annotating yourself.
Exactly.
Right? And now it's more about getting the author in there.
Exactly. That was the kind of the growth hack.
Our first paper was the Bitcoin paper.
Yep.
And so,
still the most commented, right?
Yeah, that one has a good number of comments. It has been there for the longest, and it was quoted, there are a bunch of news sites that have pointed back to it.
Oh, okay.
It's like, okay, if you want to read it, go to the annotated version. But we had a few like cool people comment there.
Lawrence Lessig commented on the Bitcoin paper.
A bunch of people from the Bitcoin community
exactly
commented there. Yeah. But the larger goal with Fermat is to try to move things in the right direction, meaning move science towards what people call open science. Mm-hmm. And so that encompasses a number of things, from open data, which means just sharing the data that you've used for publishing whatever research you might be publishing, and you want to share that and make that easily accessible to people, so that if they want to replicate the results that you got or use it in their own research, they have an easy time doing that. So that's open data. You also have just publishing the code that you used or the algorithms that you've used and making those more easily available to people. There's also open publishing, which means just publishing in papers that are not behind, or in journals that are not behind paywalls. Mm-hmm. So there's a lot of things that are within open science, all of those. And then there's also, so we want to push things in that direction and also try to build a platform that makes it easier for people to collaborate. Mm. And we think there are a lot of things that could be happening nowadays where people could be scientists could be collaborating remotely a lot more than they are, or that's at least the way we think. And but it's starting to change, where we've had the paper, the Erdos.
I think this is actually a trend. We're seeing more and more people collaborating online around papers. So for instance, there's this famous example around a problem called the Erdos Discrepancy. And this problem is a famous problem that was posed by Erdos, which is like this famous mathematician 80 years ago. And Terence Tao, the Fields medalist, was trying to solve the problem. And he put it on his blog that he was trying a certain approach to solve the problem. And then there was this guy from Germany that just wrote a comment there, like the size of a tweet. And he said that the Erdos problem had a Sudoku-like flavor. And that some of the machinery that they were using to solve the Sudoku problem could be used there. And that was actually the key to crack the problem. And they ended up publishing a solution to the Erdos discrepancy problem, which was probably one of the biggest milestones in number theory in 2016. And that was all thanks to a comment on his blog and to the fact that they were collaborating online around solving that problem, which is also was also a Polymath problem. The Polymath Project was a project started by these other fields medalists called Tim Gowers, and they were trying to it was actually a social experiment to see if it was possible to solve math problems online and collaborating around math problems online, and and they were able to solve it thanks to that comment.
Because you kind of see, right, you look at it at GitHub, and then you think of the impact that GitHub has had for open source. Open source, of course, existed much before GitHub, but it has really allowed a lot more people to come in and be able to get into open source and start contributing. And there are a number of other really interesting platforms, like, right? You have Wikipedia just for more general knowledge, or you have Stack Overflow for just programmers helping each other. And we think that there could be something similar to that, but for science in general.
Right. Well, because did you listen to the Rogan with Peter Attia?
No. Parts of it.
Okay. Mika listened to that.
Yeah.
Yeah, that was a really good one. And he talks about, I don't know if they're talking about the archive in particular around publishing papers, but he talks about having full-time staff just scrubbing the data, looking for interesting information coming out. And again, like in the context of Stack Overflow, that's the place where like programmers find specific answers to problems. Exactly. Whereas with the archive, like, good luck. Yeah. Good luck finding that stuff.
Yeah.
And so have you guys thought about addressing like just discoverability in the context of particular fields?
It's a really tough problem. Like, for instance, paper recommendations, it's really hard to...
Because you're just doing one a week right now.
Yeah.
In addition to the browser extension.
And we also have our tool that is used internally at universities and research groups for people that they're reading papers together and they add annotations there. But for now, we have the weekly journal. So we release a paper every week that we select and we annotate it, or somebody in the community annotates it. And then we have the archive extension that adds a bunch of features on top of archive, like BibTeX extraction, reference extraction, and comments, and eventually definitely like recommendation engine, and making it easier to discover papers that are relevant to you. Yeah, that's something we definitely want to add onto our archive extension. But it's a tough problem.
It is. Yeah, initially we started Fermat as João said, as a journal club, and then we saw that people liked the interface, the commenting interface, and liked reading the annotations. So now we are starting to expand and turn Fermat into more of a platform, and that's why we decided to do the Archive Chrome extension, because Archive, for people that don't know what it is, it's basically a place where papers live before they go to journals in the form of preprints. So they are like drafts before they go to journals. And what we did is we built a Chrome extension that basically allows people to see all the commenting interface on archive papers. And so you don't have to go to another website. You're just reading archive papers and you see the comments on the side if you have the Chrome extension installed.
Well, and a lot of these papers don't even have comments on another page. Like best case, you're emailing the author.
Exactly.
Yeah.
They don't have.
Okay.
So what Archive does, it's basically they just host papers.
Yeah.
That's the core functionality of Archive. And so one of the things that we noticed is that especially for areas like machine learning and deep learning, Archive is super important, because the new papers are coming out at such a high rate that people don't wait before the papers go to journals before they start working on top of it and using the stuff that other people discover. So all the papers are published on archive. And so you need a way to distinguish good quality work from bad work. If you are reading a paper on archive that hasn't been peer reviewed or something about machine learning. And I think that's why the Librarian extension is so important in fields such as machine learning and deep learning.
Does the Librarian extension have a rating mechanism as well? Like, how do you distinguish good from bad work?
Right now, it's only through the comments, but we are actually thinking about implementing some sort of rating system for papers.
And we're probably gonna we've been thinking about that for a while now, and we're probably gonna run a few surveys to our audience because you could do it in a number of ways. Like rating a paper, you could do it. Obviously, there's like likes or dislikes or upvotes and downvotes. So you could either just have an holistic rating for the whole paper. You could also imagine rating it on a number of different aspects of the paper, right? It could be about, okay, how big is their data set if they're using some data set, or what do you think about their method? So you could have a more complex rating system. And so we've been thinking about that a lot, and we're just trying to figure out what makes the most sense there. But that's also definitely we would love to add that to archive, or to our Chrome extension for archive.
Exactly.
Yeah. So how do you think the collaboration plays out then? Because I understand how, say, for instance, you're a physicist, you start commenting on someone else's paper, you start a discussion that creates a new project, right? Do you think you'll go further than there? Like, you talking about like forking and that kind of stuff?
Yeah, that's, I think you could, there's a lot of things that you could do once you have a platform that is more, that has more people in it and that they're doing more stuff in it. And so that's why the way we've been growing Fermat is with a goal far in the future where we are a much broader platform. Yeah. And so right now we were focused mostly on solving problems that people have nowadays. And actually we were largely inspired for our archive extension by the survey that the archive guys did, where they had, I don't know how many people, but they surveyed the people that use archive and then published a paper where they describe the problems that those people reported while using archive, and the things that they most wanted to see, the features that they most wanted to see. And then the archive folks just said, hey, we're gonna be the platform to build upon, and we're not gonna do all of these things that people would like us to do, but here it is. This is what people want to see. If there's anybody else that wants to work on this, here are the results of the survey. And since then, they've actually done a pretty great job of like building an API and wanting to become more of a platform. And so there's a lot of ways that we envision that you could have collaboration around science. And so, yeah, like forking a paper or forking some type of research.
Or data.
Exactly, or data. There's a lot of things that you could do there. It's not something that we're focused on right now. Right now, we're just trying to solve these problems that people have pointed out and create a place where people can just post comments and discuss around a paper.
Yeah. An example of the problems that people mentioned was, like, for instance, reference extraction. So if you go to a PDF, you have at the bottom of the paper, you have the references that they used. And most of the times when people want to search the references, they have to copy the text in the PDF, put it on Google, and try to find the link to the paper. And one of the things that we did with our Chrome extension is we allow that. They just click on a button in the Chrome extension, and then they see a list of references with links to the papers. So that was one of the features that was most requested by the archive users. Yeah. And our idea was, initially, we wanted really to convince people to install the Chrome extension. And so let's solve the hair on fire problems that they are describing here. And then once we have people using the Chrome extension, and then we can expand into like open collaboration around papers, since they're already there. So that was the.
Do you guys know of anyone working on publishing negative results? This is something that I've been fascinated with. Yeah. And like, basically the problem is that, like, as an academic, you're not incentivized to publish negative results because you want to publish things that have high impact so you can get a job or a tenure position or just get people to even care about your work, right? Yeah. And so they don't publish. Do you know anyone like working on that?
I know of researchers that they're studying that field a lot. But unfortunately, for some of these things, you just that's a very large problem, and people are becoming more aware of that. And with that, you have negative results. You also have like people doing a lot of research into like p-value hacking. Or
you should explain that.
Yeah. So p-value, it's essentially a standard that people use in order to know if the results that you have obtained out of some experiment that you've run are worthy of being published. And that has worked for the most part. That has worked fine until now. But that's arguable. But people are looking into it and thinking, okay, should we do things differently, and should we be much more stricter with what's considered the golden standard to publishing? And we've thought of doing things there with Fermat, or like just so that if you're looking at a paper, to have an idea, okay, how relevant is this paper?
Exactly.
This is more specific for certain areas, like if you're talking about medicine or biology, where that is really important, like the statistical significance of the results that you're presenting. That's all, right? That's the most important thing. And so we've thought of doing something with Fermat there, either via some API where you could like send us the DOI of a paper, and we would send you like some information regarding the p-value or something, or with the Chrome extension where you'd see that information displayed very prominently, saying, hey, like there might be some p-value hacking here, or this is very solid research, because there is a very big problem, and people are realizing how prevalent it is, especially in things like economics and
biology, nutrition.
Yeah. I mean, it came about. I was just talking to a friend who's doing a PhD at Cambridge in bio.
Yeah, it's a big thing.
Yeah, and only by attending a conference in the States did he realize that there was someone in Australia working on the exact same problem as him concurrently, and they're failing at the same types of experiments, but because they don't publish them, like no one knows the results, no one knows the methods, and essentially like these, traveling salesman type problems that people are so excited about quantum for, like trying all these permutations, are happening at a smaller scale, but no one's publishing anything. So like the progress isn't happening.
Yeah, and part of it is just the way research is done, and you come into it and you're trying to find some correlation usually. Yeah, right? You'll be trying to find some trend in the data, and you whether you are going to usually have that bias. You're trying to find some correlation in publishing that, and so you might need to change things dramatically in order to get people to start publishing negative results, which are like could be incredibly useful for other researchers. But there are a bunch of people working on that. There's this researcher at Stanford. I'm forgetting his name. It's John, and then I forget his last name. But he actually just went on this podcast, Econ Talk, and he talked.
Really? Yeah, I love Econ Talk.
Yeah, that's so great. You should listen to that podcast. And actually, Timur has been talking to that professor. I think he's a professor at Stanford, and he has analyzed more this subject, but more relating to economics, I believe. But he's found a lot of the things that we're talking about here, like they're prevalent also in economics.
Cool. Yeah. Let's go into the Twitter questions. So we have a ton of questions. You guys are very popular on Twitter. So congrats on your great following. Let's see. Let's start with something broad. Tanner Goblinstein asks, what are the most interesting papers you read in the past couple of years that are not widely known?
That's interesting. I end up reading all sorts of papers from different areas. Like,
how do you get the papers actually?
It's just like
a random walk.
Really?
It's basically a random walk. It's funny.
Yeah, or sometimes you'll think, for instance, I a few months ago I got like a Fitbit to track like my sleep, and so I wanted to read papers about sleep, and so that just got me into like a random walk around like research around sleep, and then I found a bunch of interesting things. I ended up annotating a paper about a big study in Finland that was done regards to the association between sleep and mortality. There are a bunch of really interesting things that I learned from there. For instance, that like if you sleep less than 7 hours, that's associated with higher mortality. But if you sleep more than 8 hours, that is also associated with higher mortality.
Really?
Yeah.
So have you changed your life based on that?
Yeah, no, I try. Well, not that I was usually more on the end of not sleeping enough.
Yeah.
But there's also another thing from that research that apparently sleep quality doesn't matter as much, at least for mortality, which is kind of counterintuitive. But it seems that just sleep quality is very closely related to the amount of sleep that you're getting.
Okay.
So like 7 hours of like okay sleep versus 7 hours of great sleep, that's kind of hard to distinguish.
Seriously? So you like sleep on an airplane your whole life
apparently,
and live as long?
Yeah. Wow. Apparently, maybe your life will be a little bit more miserable, but so it's hard sometimes to pick the favorites. But there is one, for instance, there's one that is also kind of random, but it's a paper published in the 90s about the Simpsons Paradox and the hot hand phenomena in basketball. So the hot hand phenomena in basketball is, right, you think that, okay, because they just made a field goal, like the next one, they have a higher chance of making it. And so there's this researcher that in the 90s looked at a data set from the Celtics to see if for free throws, if that was true. And so before they had asked students at Stanford and Cornell, like 100 students, if they thought that, okay, if they just made the first free throw, for the second one, are they higher? Did they have a higher chance of making it or not? And there was something like 68 of the 100 students that were asked that agreed, and they thought that was true. And these are like people from Stanford and Cornell. Yeah. And so then they looked at this, and so what they found back in the 90s, what they found was that actually that seemed not to be the case, right? That from your second free throw you're not more likely to make it if you made the first one. Mm-hmm. But what they found is that you're just more likely to make it on your second one.
Objectively.
Significantly. Really? Yeah.
Wow. Okay.
And so this was done in the 90s with like, I don't know how many free throws, but maybe like 5,000. They looked at some data from the Celtics.
Just across the Celtics.
Yeah. Okay. And then I went and got a data set from Kaggle with like 600,000 free throws.
Free throw shots?
And I reran the same, reran the same algorithms that they ran for the study in the 90s, and then looked at what the results were. And so the pattern is pretty clear that just on their second free throw, they're just much better at it, significantly, regardless of their first one. It doesn't matter as much it doesn't matter if they made their first one or if they missed.
Yeah.
And then that paper kind of then tried to explain why people think that there is a hot hand phenomena, and that is related to the Simpsons Paradox. Which for people that are not that don't know what the Simpsons Paradox is, it's also really kind of changed my worldview a little bit once I learned more about the Simpsons Paradox. Okay. But it's basically what it says is that you can get two valid conclusions out of the same data depending on how you split it. So an example is, for instance, that between 2000 and like 2013, the average or the median wage for high school dropouts in the U.S. has dropped. For high school graduates, it also dropped. For people with an undergrad degree, it dropped. And for people with a graduate degree or higher, it also dropped. So across the board, for all of those segments, the median wage dropped. But in aggregate, it went up. And so you look at it and it's like, okay, what's going on here? And it turns out is that what happened is that a lot more people got a degree. So they just shifted towards higher education. But so that's why you get on average it going up. And then for each one of these segments, it goes down. And so the Simpsons Paradox is that depending on how you cut the data, you might get different results. But that could be valid. In this case, it's pretty easy to understand that you should be what's the right way to look at this data. But in some other cases, it's not clear whether or not you should include this variable and cut the data in some different way. And so relating it back, like for this basketball issue, what it was is that if you looked, the results were different whether you looked on a player by player or if you looked at the aggregate. Once you collapse it all into the same table, you get different results rather than when you looked at it player by player. And so if you collapse it, I forget exactly the way it went, but if you collapse it might have been that you indeed saw you didn't see the hot hand phenomenon, but if you looked at it player by player, you saw it. And so they're arguing that that's why people add the idea. That's why you get like 68 students out of 100 saying that they believe in the hot hand phenomenon.
Yeah.
And so, so some of the paper, like that's really random.
It's just like, it's funny. You're getting these just like little tidbits of trivia out of it all.
Absolutely. Yeah.
But has it been relevant to you in terms of physics? I mean, you're working on software now, right?
Yeah. But I also end up discovering really cool physics papers. So for instance, my two favorite papers are actually were written by Freeman Dyson. Mm-hmm. One of them is when he proposed the concept of a Dyson sphere. It's just one page, and he basically explained how an advanced civilization would need more energy than the energy that we can generate on Earth. So we would have to go to a star and build a cap around the star to extract the energy of a star. But it's funny because it's like with really simple math and physics equations, he was able to derive, okay, is this sphere stable? Is it going to eat indefinitely? And so it's a really interesting paper. And the other one that I really like is one about Feynman's derivation of Schrödinger equation, and also written by Freeman Dyson. And it just shows, Feynman's intuition about quantum mechanics, and it's also really simple and easy to read, even if you don't have a physics background. But one of the things that I noticed from like trying to find papers and annotating all these papers was that in the 60s and all like through the 20th century, all these discoveries and all these papers were mostly like 1-2 pages, and it's so fun. And also fairly simple to read. But the discovery of the neutron, it's like maybe one column, just the discovery of the positron. The Dyson Sphere paper, they're really short papers and fairly accessible.
Why do you think they've gotten so long? Is it sort of like, David Foster Wallace citing a million things because he doesn't have confidence? Or like... I
think it's also a consequence of a field developing. You just have more complex questions, and so it's harder to write.
I think they're also a little bit more detailed as to the methodology, and the format of papers has gotten a little bit more formal in that sense, where people follow a very specific format, and I think that has added on to it. Yeah. But nowadays they tend like the gravitation wave, that we annotate. Yeah. That's what, like 15 pages?
Maybe. It would be interesting to analyze like the constraints in terms of size that the journals were imposing. Yeah. 50 or 60 years ago compared to what they are doing now. If they are like forcing people to write, they were forcing people to write shorter pages, shorter papers back then. Not sure, but I mean, like if the discovery of the positron paper was published today, I bet it wouldn't be just a single column.
Yeah. Well, are they intended to be more reproducible now?
Good question. Maybe. I think, or maybe it's just more complex problems that they are tackling now. Might be the case.
Yeah. It's definitely not going back. It seems like you don't really see a trend anywhere of shorter papers. But it's interesting. Yeah, you go back to the 60s and 50s, and it was pretty nuts.
Yeah. Man, glory days.
Yeah.
All right, cool. So let's go to another question. Polaris7 asks, what are the necessary ingredients in a good and impactful science writing?
This is also a good question. I don't think that I'm qualified to or like I haven't published that many papers to know that. But one of the things that we noticed, or at least I noticed from reading papers, is that sometimes it's not like the discovery paper that is the most impactful paper. So, for instance, I just remember when quantum electrodynamics was discovered, there were 3 guys working on that problem. So Feynman, Schwinger, and Tomonaga, and they were sort of working independently on that problem and publishing papers on quantum electrodynamics. And the most impactful paper was actually published by Freeman Dyson, who at the time took the time to analyze all the work and kind of unified the work of Feynman, Tomonaga, and Schwinger, wrote a paper that helped other researchers understand what quantum electrodynamics was back then, and helped really spread their work. So it was actually the most impactful paper.
So in other words, clear writing.
Exactly.
Yeah.
Clear writing at the time.
It's also, I mean, the question here is impactful scientific writing. And so you have, of course, writing papers, and then you also have just scientific writing in the sense of making some concept more, explaining that to a more general audience. And so I think there's also, it's also the same where you want to make it clear and you want to make it accessible. But for instance, even like something like the Bitcoin paper where it is like, and I mean, I studied cryptography in college, and even like it took me a few reads through it to actually get it. And it's a beautiful paper, but it's definitely not, it's a very Spartan language, and you want to read every sentence in there. And so it can be very challenging to approach it. And I think definitely you always benefit if you can make it as clear and accessible as possible, because you never know, like the audience that is going to end up reading your paper. Of course, you can expect that the people in your field are going to read it, but sometimes things can be useful, especially like interactions between math and physics. Things can be useful in different fields, and so I think it's always beneficial for science if you try to make it as accessible as possible.
What does impact mean? Does it mean number of citations?
That's a question as well. Yeah. Did you see that one?
No.
From Adam? Adam Babut asks basically the metrics for value add.
Exactly. What does impact mean? You know, if it's the number of citations that you get, or just the number of people that learn about a certain subject because of a paper. So in that way, a review paper can have a really big impact compared to a discovery paper. Yeah. And so it's one of the problems that we also think about a lot. These metrics and what are the incentives in science, and what makes people want to publish a paper, or why should people worry about clarifying a paper and making it understandable to as many people as possible. Do they have the incentives to do that? How can you create incentives to do that?
Right.
And then sometimes if the metric is just number of citations, sometimes it's not aligned to making the paper understandable and comprehensible to a large audience.
Right. I mean, is that a question that you guys have to tackle? Because, on one hand, you want to illuminate these papers that people could potentially learn from. But then on the other hand, you're running a site with content, right? And you want things that are going to capture attention. So I saw you had the Charlie Munger post on there, right?
Mika annotated the Charlie Munger paper.
Oh, okay.
Our other co-founder.
Yeah. So it's like squarely non-technical paper, but Charlie Munger has millions of fans across the world, right?
Yeah,
so you kind of have to balance those two things.
Yeah, and it's not easy, and citations are definitely a proxy, right? If the paper is getting cited a lot, it has some sort of importance, but it's definitely not perfect. And if you look at the most cited papers in these different fields, you might be surprised that there might not be the ones that you expect it to be. I certainly remember looking at like the most cited papers in computer science, and they're definitely very impactful, but you might have, some of them, I remember reading through those 10, and some of them I had never heard about before. And so, yeah, and sometimes very important. This is more specific for certain fields. Very important concepts or discoveries never really get published in one paper that then gets a ton of citations, or that knowledge gets spread in some other way. And so there are citations that are not perfect. I wouldn't say that we have a great answer for that. Okay. What's a better proxy and how you should go about it? And I don't think anybody really right now has a better answer to, or not that we've heard about. But it's an interesting problem. We'll see what people start using in the future, because you could measure impact, or how many people are talking about it on social media.
How many blog posts are written about this paper? Exactly. Or if you have code, if you have a public repo, how many forks do you have on your repo?
Or like for certain, and then it depends on field by field, right? So if you take bio, then bio papers can have a very direct, can be used very directly, say in industry, right? You can publish a paper about a drug, and then that can be used worldwide and save lives. So there, like for that field, maybe there are a bunch of other metrics that you could use there to calculate the impact of a paper. Yeah. But for the more traditional science like physics and math, sorry, it's hard.
Okay. It's hard. Question up top, Arsalan Yarvesi asks, it's basically about working in public and in the speed of publishing. They say, since scientific papers usually go through scrutiny and evaluation before getting published, how do you cope with not being always updated and up to speed in a world with daily news and contributions? This kind of relates to what we were talking about before in relation to people publishing to the archive before they really test it out. Where do you guys fall in that dynamic of like publishing as soon as possible, like with something like machine learning where things are just getting put out all the time, versus going through a peer review before getting something out?
And this kind of loops into peer review, which is a whole world unto itself that people are talking a lot about. For us, generally, or for a weekly journal, we generally are not publishing the most recent research. And there is definitely, like, sometimes there's a lot of us having to catch up to even. I remember annotating a paper about like this machine learning algorithm to play one-on-one poker, and this was like out of my league. I had to go like spend a good amount of time there researching it and also figuring out, okay, how relevant is this? I also don't, because I'm not in the field, so it's hard for me to gauge, what's the impact of this paper? So there's sometimes it takes us a lot of reading up before we can actually say, okay, this is worth publicizing and making and having our audience, or it's worth our stamp of approval and saying, hey, you should read this. I think you like it. And it can take a while sometimes. But in the future, like looping back to peer review, that's also something that I think the system nowadays does not seem to be perfect, or the way things work nowadays, and we would love to see either via Fermat or some other platform to try to tackle that and try to do something to make the peer review a better system, or to change it significantly. I think there's a lot of work left to be done there. Which can have a very significant impact in science, right? That's part of like one of the most important aspects of science is just, okay, having a very skeptical mindset, looking at it with a very critical eye, and seeing, okay, is this something that we can build upon? Is this something that we're going to add to our foundations to build more science upon this? And so that's a very important aspect of science, and I think it's not perfect and could be better. Yeah.
So Anvil Rotterdam asks, have you ever thought about building a tool for annotating books? Something like what Patrick Collison was talking about in this thread, where he basically says, I'd pay a lot more for books if I could see the highlights, annotations, and marginalia of friends or people I follow.
Yeah.
No, I think it's actually a really good question, and we have a friend, Jess Riedel from the Perimeter Institute. He's a researcher there that wrote about these on his blog, and I think that besides annotating academic papers, it also makes total sense to annotate books, and especially kind of introductory books about science. And he gives this example of a book that is used by thousands of students to learn classical mechanics called Goldstein. Mm-hmm. And there is a section on that book where they talk about this transformation called the Legendre transform, and he does a bad job at explaining what it is. But apart from that section, the rest of the book is awesome. It's really nice if you want to learn classical mechanics. But if I want to write a book that does a better job at explaining the Legendre transformation, it has to be net better than the Goldstein book,
right,
so that anyone will adopt that book. Otherwise, people would just keep using the Goldstein book. So it would make sense for books to be annotated and also be open source, so that in that sense you would just commit a new chapter, a new explanation for that, and keep all the other chapters, and then just change that bit. Yeah. Instead of having to write a new book and then convince people to adopt your book.
Yeah.
Just because of that. So I think it makes total sense to do that with more introductory.
No, and we've thought about that, the type of things that you could do. If you had some platform where you could have books that kept being updated, and you could have, okay, this is the standard for learning calculus, mm-hmm. where this is constantly being up to date. You're adding exercises to it. People are forking it. Like if you need more information about this, you're not understanding it, you could deep dive into it, and you have a bunch of additional content that is attached to it. Really feels like something that should exist, and we've thought about it, about doing something with Fermat for that. It's so many things.
Well, just in terms of copyright, are there massive issues there, or is that possible?
I think you might be facing some of the same challenges that Wikipedia is facing to an extent. I think it would depend a lot on the format that is used. I do think there's for something like this, you'd probably benefit from having some editor or like a team of editors to curate and to see, okay, what, like, should we add this, should we not, to an extent, to be a curating voice. In terms of copyright, you could run into some issues there.
Well, some of these, especially the classic books, like on electromagnetism, or like,
they're out of copyright. Yeah.
A lot of
I mean, my impression was that these are maybe even like current books coming out, like popular fiction, even as annotated by X famous person. So I mean, maybe if they gave away their notes for free and they were just a layer on top, then you're good. But if you wanted to, resell your own version of the book.
Yeah, that's interesting. There's also some, right? There is some legislation. Well, there's fair use where you can use a piece of content if you're adding onto it, or like, right, this is why you can have like a video on YouTube with a snippet from a movie if you're reviewing it. There's some precedent there for doing this type of thing. But for more general books, I also agree that it'd be amazing, because we were just talking about this. We've talked about this for a while now, but right, because you read a book, and the purpose of that book is not only for you to absorb all of the knowledge that is there, but it's also to get you thinking about what's being talked about in the book, and then you might reach some other conclusion. You might go on a tangent, and when you're reading it, that knowledge might never be shared with anybody else. You might just read it yourself, and you think, this just made me think about something else, and it would be really like there's a lot of knowledge that is being lost. And it would be great if you could capture it in some way.
The Amazon Kindle Highlights site is one of the saddest things I've ever seen.
Yeah.
Have you ever done that?
We have Kindles, but
we haven't explored it.
Oh, yeah. So there's a whole web interface for looking at all of your highlights across all of your Kindle books. It's not good.
So do you use it for anything?
I mean, sometimes I go back. So like the best way that I've found for me personally to retain is to buy the audiobook and go through a book a couple times. And then my retention goes way up. But occasionally I'll be just like, what was that passage in, whatever book? And I'll go back onto Amazon and you can dig.
It's from Amazon.
Yeah, and you can dig through your highlights from your Kindle.
I think I've seen like a startup that does that in a better way. Kind of pulls all your highlights and organizes them. On the Kindle highlights.
I remember looking into this, but what I've started doing is, well, if I'm ever, I also use Kindle, and so that's I don't usually don't write annotations via Kindle some way or highlighting. I usually don't use it for that. But if I'm reading a physical book over the past, whereas before maybe I would never write anything, now I try to like write a lot more there. Yeah. And then at some point, if I have time to try to go through the book, see where I wrote things, and then write that in some notebook.
Right.
And because there is like just going through that exercise of looking what you highlighted can be very helpful.
Yeah, I mean, even I was an English major in college, so like I've forgotten more books than a lot of people ever read in college. And one of my professors actually recommended this, which is basically you take a 5x7 index card, and as you're reading the book, you're making little notes, right? You're like, all right, this character does this, or like this is an important point. And then at the end, you basically write a paragraph to your future self describing your memories of the book and what happens and like important ideas. And that can really like trigger it for you to retain. But past that, like, I don't know.
No, but I remember in school, or back in Portugal, we all have to read this epic poem that is like, it's called the Lusíadas. And it was written by a poet back in the day. It's about the Portuguese going from Portugal all the way to India. The Portuguese discoveries. And so I remember we had a version. You had the original version, which is pretty thick, and then we also had the version that had annotations on the side for each verse, or not for all of them, but for a lot of them, and that made such a big difference, right? Because you're reading in old Portuguese, which by itself is already hard to tell, and then he's making references that you have no clue about.
So much historical context in every word, almost. It was
right. Like the names of all, like India was not called India, so like right, there's everything is different, and you're reading it through. The first time you go, it sounds great, it rhymes, but you don't understand a lot of the context behind it. And if you go through it and you read through it, and then on the side you have all this rich content that really only adds on to your experience and makes it much more memorable. You can map it out in your mind and create much more connections. It really enriches your experience. And of course, you have this because in this case, this is an epic poem that everybody has to read, and so there's a large incentive to publishing the annotated version of this book that is no longer under copyright. And so there you can have those type of things. But for a lot of more recent books, I think you could benefit a lot from having that to some extent, right? Where you can, if you're reading through these few pages and you love what the author is talking about here, you want to dig deeper into this topic that he's talking about right now, there should be some place where you could do that. But it's just nobody has actually built this.
I mean, I think that like defaults toward the blogosphere for most people. They just like, some people summarize books and like write Amazon reviews and
But then the thing there is that, and sometimes that content does exist, but being able to find it easily, having that like in your fingertips can make the whole difference, right? Where even if you, maybe you could spend like a minute like searching on Google and you'll find the content that you're looking for. But if it was right there, you could just click and it would pop up and you'd see it. Then it would be much more likely that you would end up reading that content. Those type of things make a big difference being right there.
Do you find that annotations sometimes are best done by someone who is not the author of a paper?
I what's interesting is that the authors of the paper sometimes they are not going to know where people are going to struggle understanding the paper. Oftentimes, I remember when I was annotating the Ethereum white paper, right, written by Vitalik. I went through it and then I emailed him, and it's super quick to reply, and he replied back with some of the questions that he gets the most about Ethereum.
Makes sense.
And then, but when you're writing it, you have no clue. You've worked it out in your mind. Some steps you might skip because you just have internalized them by so much. So you only get, you only know where people are going to struggle once you put it out there and you start getting questions. And so, so sometimes the authors are not the best.
Every time we talk with an author, I think it's easier for them to answer questions about their papers than to annotate the paper. But then if you have another person annotating a paper, I think it's easier for them because, with the authors, we see that a lot. Just ask me questions, I'll answer them. But sometimes I don't know how to enhance or add content to my own paper.
Yeah. You guys could provide that service for sure. You could like reverse engineer clear papers. It's kind of worth noting that this is a side project for you guys. I mean, I have so many questions about like how you go about building this thing that's like definitely consuming a lot of your time. I mean, it has to, right? Between reading papers, making all those like graphics and tweets and stuff that you guys do. How do you find that balance? Like what's your whole philosophy around this?
So it definitely takes its time. It is something that we actively tried to do after college and while we were just before doing Fermat, reading papers and staying up to date. It's something that we tried to do anyway. And so we were already looking into research before as just something that we would enjoy, and then we found it good to have some sort of peer pressure amongst ourselves to present papers to each other, right? Because that really forces you to understand something well, right? Where I think it was Feynman. He has some quote where you don't understand something until you can like explain it to some freshman or a freshman in college. And so that is that's very true. And so we tried to do that amongst each other, and so then we got to Fermat and we thought, okay, maybe we can bring this online. And so we were already spending an healthy amount of time doing this type of stuff. But with Fermat, you have to, like the first version of Fermat, we kind of build it over the weekend and we try to just make it, just put it out there as fast as possible. And then it's mostly like late at night. I'll be trying to fix bugs. People in Hacker News don't seem to think that it's a side project, and they're pretty harsh on it. So there are definitely bugs, and sorry about that. We try to fix them when we have time. But it definitely takes its time.
But I think it's also something that all of us really like doing, and I mean I start looking at Wikipedia articles about quantum computing, and then I like spent 3 hours clicking on articles, and then I found like 5 papers to annotate, and I've produced like 10 or 15 tweets. So it's something that we really enjoy doing. And so it's
I think that's the real genius of it, right? It's like basically figuring out a way to turn if you have the desire, turn what would be your hobby anyway into this little side project.
And having a forcing function. Because this type of thing is really easy to let go, right? Because sometimes you might not feel like understanding a paper to the point where you could annotate it. They're like it takes a while to get a good grip, especially if it's not an area that you're super familiar with.
Of course.
And so it's not that's definitely not the type of effort that you do on a Saturday night, right? Unless you add a forcing function that you know that within a couple of weeks you're going to be putting this to a lot of people.
That's my favorite part of the podcast. Like with the software stuff, it's pretty easy for me to just like, it could be anyone in the room and we can do a podcast. But when we do physics ones or anything or math or something, I'm just like, oh my God. I have to take a couple days just reading because I obviously I couldn't even become an expert if I dedicated a week to it, but I want to be conversant to a certain extent, and that part's fun.
Yeah, same with us. Like, you definitely feel the pressure when you're writing these annotations.
Yeah,
because people will call you up on it, and they'll be like, "Okay, this is wrong," or "You missed this." And so when you're writing it, you want to be really careful, make sure that what you're saying is correct, and you know that you might have somebody that actually a college kid or whoever that is reading through that paper and then is going to use your annotation to help him understand. And so you have the responsibility. We feel that responsibility towards those people to do a good job at it, and to when we put an annotation, we want to stand by it, and we want it to be of quality.
And it's funny, it's like the more you annotate a paper, this is like a circle, and the more you annotate a paper, there are more people there are that are at the edge of starting to understand what the paper is about. So you start getting more and more questions because the circle expands, and then you just have more people that are like starting to understand this topic about number theory or physics or whatever. So you get more and more questions about the paper. So it's like, and then when do you stop explaining a certain concept? So it's like, you want to annotate a paper about number theory. Okay, do you have to explain what a prime number is, for instance, or do you have to explain what a rational number is? So it's really interesting once you start thinking about that like how deep do you go?
Yeah.
And
well, you got to be careful about those YouTube videos then, because if you get discovered on YouTube as an explainer series, good luck.
People will start asking. Yeah. No. We've done a few of those, but
we've annotated a paper that it was, I think it was a proof of the irrationality of the square root of 2, and then there was this I think it was 14-year-old kid from Russia that because of that paper he came out with an alternative proof for that, and he sent us that proof, and I read the proof, and it was apparently
legit.
Yeah, and I told him to submit that to a journal, a math journal, and I think he did it. I haven't heard back from him, but we should reach out to him to see if he actually was able to publish it. So it's also nice to see, how we can inspire people sometimes to do these types of things.
Absolutely.
And I also think, especially with Twitter, one of the things that we learned is that learning a concept or learning a fact is really, really addictive. And we see that on Twitter almost every day. People come back, and we have hundreds of thousands of users that read our tweets, and I think that's why people really like when they have a good teacher, and when they can go to a class and really learn something. I think the problem is that usually that requires a lot of effort from people. You either have to go to a class or you have to read a book to learn something. And I think what we're able to do with our Twitter account was to provide that same feeling, the acquiring a quantum of knowledge, but at the cost of reading a tweet, which is really easy for the reader. Sometimes it's really hard to make those tweets. It requires a lot of reading and thinking, how can you explain something with just these characters and an image maybe. But once you get to that, and once you're able to teach someone a fact or something, people really like that. And I think it's something that there should be more people exploring that on Twitter. It's a very particular medium.
But there's a lot of people that are attracted by that. You might not. You might not. A few years ago, I would have been very surprised, but now you have all of these scientific, or be it explainers, but you have people that have millions of followers, and what they're following for is for scientific content, or they just want to learn. Yeah, and so that's something very uplifting that we've learned, that there's a lot of people out there that want to learn.
I think it's too easy to get down on those people. Yeah. They're just like, oh, this is like base, it's fun facts or whatever. But like at the end of the day, like that's good.
Yeah.
Like, people are excited to learn. They want to learn. And then you like extrapolate it out a little bit more, and you look at someone like Dan Carlin doing the Hardcore History podcast. I think if you had objectively like written that down, you're like, all right, I'm going to produce 25 hours of content about the cons, and people are going to be into it, I would have told you no fucking way.
Yeah.
And then you look at it and it's like millions and millions and millions of downloads.
Yeah.
Like, that's pretty cool.
There's some things that you look at it and it really catches you by surprise. I mean, this is parallel, but it's like Wikipedia, for instance. If somebody had pitched Wikipedia to me before Wikipedia existed, I would have never guessed that would be possible.
Yeah.
Because like, how are you going to do this? Like, no incentive, just people are going out of goodwill. They're going to add content to it, and it's going to be good content, reliable things that you can use to learn. And that's just right. That's not something that you would initially think would fit with human nature. But people surprise you for positively, right? And the same goes for like Stack Overflow. Like, people just out of goodwill, they will go out and explain, or try to help you solve your problems. Like, there's something to be said that like humans have like some untapped fountains of goodwill that we might not be leveraging as much as we could. Yeah, you see bright spots here and there, and like Wikipedia or Stack Overflow, it's all projects that if you'd pitched them to me before they existed, I would be very skeptical that they would be able to get to the point that they are today.
Of all the parallel universes, we are in the universe where Wikipedia exists.
Exactly. There's got to be a lot of parallel universes where Wikipedia
didn't survive.
Yeah.
Yeah. Well, absolutely. I mean, it's like when you talk about you guys expanding, you almost don't have to over-engineer the incentive mechanism. If you believe that is true, right? Like, annotating more papers is objectively interesting.
Exactly.
To people.
Yeah, for sure. We have people, I think. We'll always have people that are going to be interested in consuming the content and reading. Then you have the other side. How do you create incentives for people to annotate the papers? I think that's a different game. But yeah.
Some things is just that it takes some time. And we are totally, when we started this, we knew that it would take time until people cared at all about what you were doing. And then it takes even more time to make any sort of impact on the issues that we care about. But for a lot of these things, even say, if you look at Archive, Archive was started in it's my age. So it's like started in August 1991. And it has taken a long time to get to where it is today. And if you look at the graph of submissions for Archive, it's completely almost linear.
Yeah.
There's no startup exponential hockey stick growth. It's like completely linear, but it's arguably one of the things that has had the most, or that has impacted the making of science or the distribution of science the most. But it just took a while to grow, and it seems like it's just going to keep growing linearly. But sometimes that's what you need. And so we are totally mindful of that, and we know that like this might take a really long time until you can get to do what our ultimate vision is and to build that out. But some things they just take some time.
So do you feel pressure to achieve like profitability or even like sustainability in the business of it all?
Not at all.
We never really thought about that. Because also, probably because this is a side project, we never really thought about monetizing or achieving profitability. It is like for some of these communities, or like Stack Overflow, it's a for-profit company, and I think it does a great job at what it does. And I'm probably happy that it is a for-profit company because they're just more independent, and if they have a good leadership that takes it in the right direction, it's great because they don't need donation to ask for donations to keep going. Wikipedia is a nonprofit and they've been doing great. So it's possible to do it both ways. We've just, because we have very limited resources, we try to focus all of our attention in the areas that are the most important into what we're trying to achieve. So that means like we have to prioritize. And so meaning like our next step is going to be building the Chrome extension for Archive versus doing anything else, because we think that's what has the biggest impact. So that's why we never delved into profitability, and we just paid the costs ourselves. It's just server costs because we do all the work. So it's never something that has been in our minds a lot. And we think you could build these type of platforms either for profit or non-profit. So yeah, just something we will kind of defer it further down and into the future.
It's a good question. For instance, could have archives survived if they were a startup, for instance? If they were for profit.
Yeah, right. Could they raise money with that kind of linear growth?
If they were not inside a university.
Right.
Yeah, it's a good question.
Yeah.
I mean, plenty of companies without, startup growth raise money and become profitable or sustainable.
Oh, absolutely.
Yeah.
Right. But you're just like, okay, what are you going to charge for to get people to care? Because, archive is great because it's open.
Exactly.
Right. And so many other journals may be dying out because they're not.
Yeah.
And
absolutely.
Absolutely. One of the trends that we've also noticed is a lot of people building journals on top of archive. And we are even collaborating with a few journals, one of them being the Quantum Journal, which is an overlay journal on top of archive on the quantum physics category. And what they do is basically, so what is a journal is just a list of links to papers, and so they don't have any hosting costs. They just have a page where they just have the links to all the papers that they decided to publish, and all the papers are on archive. So it's completely open. And what our partnership with them is basically all the papers have the Fermat's library commenting interface. But we are seeing more and more of these journals popping up. So, for instance, the Erdos Discrepancy solution was published on one of these open journals called Discrete Analysis. And I think it's totally possible that these open journals get to a point where they have a reputation like science or nature, as long as you convince people to publish their papers on these journals. There's nothing about science or nature that is unique to them and that prevents these open journals to get to that point. Yeah, of course, it's also going to take time, exactly. But I think it's totally possible.
Yeah, exactly. It is. A lot of people talk about this, right? Where you have journals that put content behind paywalls, and that content might have been funded with public funds, and so right there's that whole discussion about that, and it is a tricky system to get out of because it is sort of in a stable equilibrium to a sense, right? Because if you're a researcher, you need that publication in Nature or whatever to get your postdoc position in a renowned university, and so you have incentives for the status quo to persist. But there are a few ways that you could get out of it, right? As Luis was mentioning, one way is for these open journals to start gaining more reputation, right? And so that if getting published in Discrete Analysis, it's a big deal, and it has a lot of reputation attached to it. And once that starts to happen, like you get more and more people just putting it all out there and on archive and publishing it all in open journals. The other ways that you could get out of the system would be for specific fields like what we were talking about in machine learning, where you have an incentive to publish as fast as possible because the field is just moving so quickly, and nowadays journals or big conferences
might take years sometimes.
Yeah, a lot of time for submitting it until it actually gets out there, right? If you're submitting to NIPS or whatever for machine learning, it takes a long time for it to actually be officially published. And so you also have that incentive that if it's open publication, you can move much faster. And so it is a sort of a tricky equilibrium to get out of, and that's why these companies that make billions of dollars in revenue.
And for instance, one way to get out of it was just, and I think it's one of the ways that they are probably, it's probably the way to get these open journals to be as popular as Nature or Science, is to convince really people that already have a tenure or really famous scientists to publish on those journals. You already have your position. You already have your Fields Medal, your Nobel Prize. Just publish on an open journal, and that's what Terence Tao did with the Erdos Discrepancy, and I think that's what other people are doing. And Tim Gowers, which is it's a field medalist also, this mathematician, which founded the Discrete Analysis Open Journal. And I think he wrote a blog post a while ago, and his mission was to convince famous mathematicians and people in these situations to publish on open journals.
Yeah, because for the young researcher that is trying to get a position in an uber competitive field, then you need, right? Because if you want to get your postdoc in a renowned university, you need to have that. Yeah. So that's what's keeping it alive. So these big names endorsing the open journals.
I think that's going to be the growth hack to increase the reputations of these open journals.
Absolutely. And it was interesting because it is a problem, and we definitely believe that that's the right direction. And while you're in the U.S., right, like while I was studying at MIT, you don't even realize it, because if you're within the MIT network, everything is open.
Yeah.
Right. So you're accessing it. And when I was an undergrad, I didn't even realize. In
other words, if you're literally on the MIT Wi-Fi, you have access to these journals that are paywalled,
and you don't even see. Okay, would be $30 if I was like 5 blocks down that way. But Luis was studying in Portugal, and so we would talk, and then you'd compare, even in Portugal, where right, you have well-funded universities, but the research groups might not be able to afford all the journals, and so sometimes you just have a lot of trouble accessing research.
Yeah.
And so this is not in the US. It is like big institutions have access to it, but like in a lot of other parts of the world, the fact that a lot of research is being published in non-open journals, it has a significant impact.
Yeah. Well, especially when like legit CS papers are written by people who aren't associated with any university, right? They're just like hobbyists writing things. Like, why would they have 100 journal subscriptions?
Exactly.
It's impossible.
Never.
Yeah, I remember even like researchers in my research group, sometimes they would have to go through CERN to get
through CERN
VPN through CERN to get access to these papers. Yeah. Or like I would have to email you and ask you to send me some PDFs.
Yeah. You're a good brother.
I contributed.
Yeah. $5. Cool. So if someone wants to contribute or help out, what can they do to help you guys?
I think there are a few ways that you can help us out. You can annotate a paper on Fermat's library.
And so email us, team@Fermat's library.
Exactly. If you want to annotate a paper there.
Could spread the word. And if you're at a university, then we are...
if you have a journal club, if you have a research group and you want to annotate papers and share them among your peers.
When you create an account on Fermat, like now you can also upload your own papers. You have that option, and then you can share with whoever, and you can create your own lists. And so we have people at universities that use us already, be it for classes and students have to read papers, and so they will post annotations on Fermat, or just within research groups, and they all decide to read a paper. So if you're at a university, and if you want to use this, it's completely free, so you just need to sign up.
Yeah.
Those are the two main ways that you can help us out. We're also taking cryptocurrency donations. So there's that. But really, most of our costs are just server costs, because it's all so we don't have to pay salaries to anybody. So so that's about it.
That's the way to help us.
Cool. All right. Thanks, guys.
All right.
Thank you for having us.
Yeah.